Hi there. So what an exciting week for the open source world. So with this new model, Llama 3.1, open source models are at par with the commercial models. And if you see the evaluation benchmark, you will be totally blown away. So basically, Meta has come up with these new Llama 3.1 models, and definitely everyone is excited about them. And what we are going to do today is we are going to take a smaller Llama 3.1 model, like 8 billion model with 8 billion parameters, and we are going to see its performance in one of the use cases, again from merger and acquisition domain. And we are going to fine tune it for our specific use case, and we'll try to see the results as such. So let's get started. So with this video, I will be releasing these two notebooks. And all these notebooks are from Unsloth. So big kudos to Unsloth for their examples. And there is nothing unique here. The only thing which is unique is, what I have done is I've just tried to compare, fine tuning for one of the use case, and definitely I got good results, and that's what I'm going to share with you. So basically, what we are going to see is we are going to see two Colab notebooks. In one of the notebooks, I use the Llama 3.18 billion parameter model directly, see the results, jotted down the results, and in the second notebook, what we did was we again fine-tuned for that specific use case, and we saw the results. And what we are going to see is there any improvement in the results or not? So that's what we are going to do. So let's get started with the first notebook, and it's pretty simple. So basically, what we are trying to do here is we are just doing a mounting of our drive. Then we are just checking Python version, and I will skip all those steps. But here, what we are trying to do is we are installing Unsloth library. Unsloth is for fine tuning our models. And if you see, I'm using L4 high RAM, and this is exactly the configuration you can use to smoothly run this. So we installed Unsloth with other dependencies. And once we installed it, what we are using is we are just loading one of the model again from Hugging Face, which is hosted by Unsloth itself. So when you go to Hugging Face, Unsloth as such has prepared this 4-bit model derived from Llama 3.18 billion parameter model. So basically, what here we are trying to do is we are just loading the model and the tokenizer in 4 bits using bits and byte libraries. So basically, you are just loading the model here. And what we are trying to do here is this is the alpaca format that we use to get the answers directly. So once you load a model, once you load a tokenizer, what you can do is you can directly pass it the example that you wanted to get the answer from and see its response. So basically here the format is below is the instruction, and you have to do this, then you have the instruction, then you have the input, and you have the response. And what we are going to see is we are going to provide it in one example, one instruction, one input, and we are just going to see what the response is. So this is the alpaca format. Now here is the thing. So basically what we are doing is we have this input, which is a news article, and again it's from merger acquisition. We are providing it two instructions. So one instruction is what is the acquisition date, answer precisely, and the instruction two is which company is the acquirer, answer precisely. So we'll use it two times. So one with instruction and the input, then with another instruction and the input, and we are going to prepare this in particular format. So that's what we are doing here. We are preparing it in a particular format because Llama 3.1 expects this particular format to be fed into it so that it can answer. So this is exactly what we are trying to do. So it's uh, concatenating everything with some special tokens and all. So basically these two things are appended and a special token is made, and that's exactly what it's doing here. So below is an instruction that describes a task and so on. If you see, this is exactly what the format is. Then it will give the instruction. Our first instruction is what is the acquisition date. answer precisely. So exactly this is what it's trying to do. And the input is our news article. And this news article, HCL Technologies is complete acquisition. This is what it is going to provide, and then a response. And this we are giving it to the model to get the answer. Now, what we need to do is, if you see this, you will have to use this boilerplate code. And what we are doing is we are again, trying to combine the instructions and the input. So just like this input will be created. So I just created this example to show exactly what will the final string will look like. If you see here, basically that's exactly what we are trying to do. We are just trying to, get this thing created in this format, and then we are, tokenizing it, and then we are giving it to the model. And again, I will not go into much details as such. So basically, the output that is generated contains many things. What I have tried to do is I just try to get the actual response. So once you get the final output, you also get the prefix of all these things which uh, throw to the model. That's exactly what I don't wanted to see. I just wanted to see the response. That is whatever is coming after response. That's exactly what I wanted to see. So basically, we have given an instruction of what is the acquisition date. We have given it a news article, and it gives January 05, 2022, which is the correct date. So basically, if you see, the correct date is January 05, 22. So it was able to give the response. And then again, the next question is, who is the acquirer? So again, we are saying which company is the acquirer, answer precisely. And that's exactly what it did. So, it formed the format, and then it gave the response, HCL Technologies is the acquirer. Now, there is one potential problem with this approach. The problem is, although this answer is right, but we wanted to get the exact text rather than something which is appended at the end. So we wanted to get the answers precisely. So what we have done in the next collab is we provided it some raw examples with actual outputs, which are like exact precise outputs. And we asked the same questions again. And maybe what we wanted to say is, does it able to understand what exactly wanted to do? That is to extract the answer precisely and not add anything extra. Like for example, TCS Technologies is the acquirer. So the correct answer is HCL Technologies and not the is the acquirer. So in the next collab, we'll see whether with fine tuning we can achieve this or not. So let's see in fine tuning it. So here we are fine tuning it. So if you see, I am already using L4 high RAM, and we are mounting our drive, checking the Python version, then installing data sets. Again, this step is something which is not given on Unsloth. And what I wanted to do is I wanted to create a data set just in time and then use it. So basically what you can do is you can use this data set. You can create your own data set, replace this with this specific examples, and you will be ready to go. So exactly, if you see last time in the last collab notebook, what we wanted to do was we wanted to find out, who is the acquirer and those sort of things, and we wanted to get the answer precisely. So what I've done is I've given it instruction, which company is the acquirer, then the input, which is a news article, and the output, which is the precise answer. So nothing is appended; it's a precise answer. That's what we wanted to do. And if you replace it for your specific use case with instruction input and output, you will be good to go. So this is exactly what I've done. And that's why I installed, datasets library. So I created these, datasets with, instruction input and output. Then what I'm trying to do is I'm installing Unsloth. Pretty much all the dependencies will be installed by itself. Like for example, PEFT bits and bytes and so on. Then what I'm trying to do is I'm just loading the model. So there are like some parameters, for example, what will the maximum sequence length, and we want to load it in 4 bits using bits and bytes. Those all information is there. So here we are loading the model as well as the tokenizer. And what we are going to do is in the next step is what parameters we have to, fine tune exactly. That's what we are providing to it. So again, pretty simple boilerplate code. And once we have this, what we are trying to do here is again maybe explained in the earlier collab notebook. So we have this alpaca format where it expects the answer in terms of instruction input and the output is a response. So what we are doing here is using that particular data sets that we created. So those, 10 merger and acquisition example, we are putting it in this format. So for example, there will be instruction input and definitely since we are training, we already know the response. So that exactly we are trying to do. So we created a data set and we, try to pass this input to the training module. So basically, instruction input and output they are appended in alpaca format in terms of text. So text will be something which is a special format like this, and it contains or it appends both instruction, sorry, all three things like instruction, input, and response. So once it knows what is the instruction, what is the input, and what response to get, it automatically trains. And then what it is going to do is when we are going to provide it the raw data with only instruction input and not the response, it is going to give us the response. And that's exactly what the agenda for that particular fine tuning is. We'll see what the response is compared to, you know, uh, seeing a non-fine tuned model. What is the response of this fine tuned model? So we provided this specific, format to it and then we are training this. So with all the hyperparameters we are training, and again, this is somewhat boilerplate code in terms of unslot. So this is used for almost all the models. Some parameters might be different. So if you're using Llama and all, you might have parameters which might be slightly different. Since we are using this Llama 3.1, these are the parameters which we are using. So once you do, you are done and here is the actual steps. So all of these things are like how much memory is there and so on. These are the actual steps where it is training. So you can see each steps, what is the training loss. And if you see training loss is decreasing, which means definitely it is learning something. After some times it stops. And what you are trying to do here is you are just trying to save this particular model in different formats. So basically, if you heard about Olama and all, you can save this particular model using unslot in all those formats and those all sort of things are supported. But what we are going to do here is we are again going to test our, two instances with the earlier response and we'll see once this model is trained, what are the responses, how they are different from the last time. So if you see last time, we had a question of what is the acquisition date and which company is the acquirer. That is what we gave to it. Now, in terms of, acquirer, like who is the acquirer, we saw that, it appended something which was not needed. So we'll see whether, with fine tuning, did it manage to, get the precise answer. So if you again, I'm just covering it again, what we did was we just provided it the acquirer example and not the dates example. So basically we just fine tune for, finding out the acquirer and we gave it some results and then fine tune. So now if we provide it examples, let's see what's the difference. So we say, what is the acquisition date? Again, it's January 05/22, no change there. We have anyways not fine-tuned for this specific problem. What we have done is for the company, which company is the acquirer. We wanted to have the exact result. And once we pass it the next question, which is which company is the acquirer from this news, give me the response. It gives exact result HCL Technologies. Prior to that, if you see, it says HCL Technologies is the acquirer. So without fine tuning, it was appending something which was not needed. Now with fine tuning, it's giving us the precise results. So that's the power of fine tuning. If you wanted to tilt our results for particular domain as such or particular task, we can use the fine tuning. So I will be putting these Colab in this particular video. As such, I will be making it public so anyone can use it. Uh, thanks team. Thank you all. Bye.